Hi, I'm Nick Eberts. I'm a product manager at Google working on GKE. The idea for this talk came from feedback I received during a presentation I gave earlier this year at Google Next. The presentation was a 45-minute live demo where I built as much of an internal developer platform as possible using the GKE UI. By the end, I demonstrated how a developer could self-service by creating namespaces and continuous deployment without needing admin access to clusters. Now, the feedback was overwhelmingly positive. However, one person out of the hundreds who left feedback mentioned that while the talk was great, it didn't focus on building an IDP. This feedback stuck with me, and this talk is dedicated to addressing that perspective. I firmly believe that creating a multi-cluster, multi-tenant, fungible infrastructure base layer is fundamental to building an IDP on Kubernetes. Based on my conversations with at least 50 customers a year over the past 9 years about Kubernetes, I can tell you that this approach is the prevailing trend among Kubernetes operators. This aligns with the approach many of you might already be considering when planning your fleets of Kubernetes clusters. First, let's start with the story. On day 0, Charlie, the platform engineer, creates a streamlined golden path for Kubernetes clusters with a new shiny self-service portal, right? So now you have an IDP portal ready for click and deploy operations. Great. So the first user comes along, Bob, and he says, hey, I want to launch a dev cluster, goes through the entire process and successfully creates a cluster. He receives credentials to that cluster and then starts kubectling to his heart's content, deploying applications and just enjoying the experience, right? Then in the following weeks, that initial success expands. 2 more teams have onboarded, each with their own dev cluster. Now we have 3 clusters. Everything is still manageable. For Charlie, the platform engineer, life isn't too complex. Managing 3 clusters is quite doable. No problems, right? However, we don't deploy customer-facing or live applications in development environments. Therefore, we also need production clusters. In addition to production clusters, we'd likely to have staging environments to test releases beforehand, just to ensure that we don't break anything before deploying to prod. Not everyone requires staging clusters, but that's minimally what I see out in the wild are 3 environments, sometimes more. Either way, you can see that we now have more clusters to manage. Even if we just have dev and prod, we've doubled, right, from 3 to 6. And if it's more likely that you have those 3 environments, you've got 9. But what happens, so that's manageable, right? Not too hard. But what happens when we become really successful and the number of clusters grows significantly? Right? Now we have all these teams and clusters, and Charlie, the platform engineer, the admin, his life is becoming quite challenging. He has to ensure that all the clusters are secure and compliant with security and governance. And then, there's a stream of tickets coming in when any particular team breaks something beyond obvious repair. It is not awesome. Okay. So at that point, Charlie was never seen again. Rumor has it he drowned in a sea of Kubernetes clusters. Dad jokes. I have to have at least one per talk. Anyway, bam. So here's my pitch. Don't drown in a sea of Kubernetes clusters. Take control of your fleets of clusters and abstract the tenancy model away from those clusters. Now, that's a big mouthful, so let's dive into what that actually means. First, you likely need to group your clusters, and in GKE, we refer to these groups as fleets. Organize your clusters into application lifecycle environments. For example, you would have separate groups for dev, staging, and prod with several clusters to hundreds of clusters in each environment. What you're really doing here is building a system of fungible clusters. This means that whenever you add a cluster, it adheres to the minimum set of configuration tooling and security governance established at the base level of all the clusters in the fleet. On top of this base configuration, you might have different shapes of clusters. So let me explain a little bit more, right? In a large-scale production environment, the applications and their distribution across clusters are unlikely to be homogeneous. You can't just replicate every cluster in the same way because there will be significant variations. Different apps may require different security configurations. For example, maybe you have PCI and non-PCI compliance environments. But within this context, we introduce the concept of shapes. A shape refers to a grouping of applications that you want to run together because they bin pack nicely together and share similar security and governance concerns. Within a shape, you can consider it a homogeneous group or a homogeneous pocket of applications within the fleet. If you need to add capacity to a shape, you simply add a cluster. And everything aligns with the fleet-wide and shape-specific requirements and comes up to state and just starts serving that application. So this approach kind of forms the infrastructure foundation for building an IDP on Kubernetes. Platforms are platforms because they're running applications. No one operates platforms just to have idle computers wasting resources. The next part we'll discuss is how to organize your tenants and teams within these fleet environments, right? Now, where a team represents a concept that allows you to group multiple applications or namespaces together that are all managed by the same people, right? And in this case, I'm talking about the people who manage the tenant Could be developers, could be app operators, depends on how your organization's laid out. So when you organize these teams, you don't have to get it right up front, but you do kind of take a swag. The benefit of abstracting the applications inside of these teams away from the infrastructure is that you should be able to adjust how they're bin packed into shapes over time. A team could encompass multiple namespaces. It might just be one, but most of the time it's going to be more than one. And we recommend treating each binary that a team ships as a separate namespace, right? So each container image that you ship should have its own namespace. Of course, there are exceptions. Like, for example, you have multiple containers. And I don't mean multiple containers in the same pod. The sidecar pattern is different. I'm talking about multiple containers that have different dev life cycles, but are strongly coupled to each other. Like, there's zero chance that they'll ever need to be broken up or turned into a shared service. They're always going to rely on each other. Those types of binaries could run in, 2 deployments, for example, in the same namespace. But typically you want to have the flexibility of having a namespace per binary, because then it will make it easier to move namespaces around and shift them to different teams over time as maybe your team's responsibilities change. These things happen. So you can see that whenever I add a cluster, because I've done all that work that we talked about, whenever I add a cluster with the correct label of an app shape, it will come up to the state not only with fleet-wide configuration, but also with the specific shape configuration. Additionally, it will include the actual services that are running within those teams inside of those shape. So I like to call this the layer cake of configuration, but it's a good mental map and structure to allow you to start to lay out how you want to build your base level config, your shape level deltas, and then your actual applications and how they're bin packed across your fleet. So once you establish how you want to manage tenancy on top of Kubernetes, once you have everything set up, adding capacity becomes straightforward. Adding capacity can mean adding a cluster to a team's specific shape. Autoscaling can handle many scenarios in which you need to add more capacity. However, sometimes adding capacity is not just about scaling out a cluster or the applications within that cluster. It's about maybe adding high availability or stretching into another region that's closer to your customer base. So adding capacity is as simple as adding a cluster with the right label and having it come up to the correct state. A crucial part of this process is setting up service discovery and load balancing within clusters of the same shape. You could see that because we're using, in this example, a multi-cluster mesh, I've got service discovery across those clusters established. So whenever a service comes up and it has the same service name, it then can participate in that as endpoints within that service, regardless of which cluster it's on. And then if you're using a mesh like Istio or something like that, you could set destination rules that establish a priority, like try to stay local before going to another cluster. And then also equally important is how you get into the cluster. Multi-cluster gateway, part of the new gateway API spec. There are implementations of multi-cluster gateway out there that allow you to have a single load balancer that distributes traffic across multiple clusters, right? So that whenever you add that service to a new cluster comes up and that service then becomes healthy, it participates in the back end of that load balancer. So if you have this north-south and east-west networking established across the shapes, adding a cluster and then installing the services in the cluster just based on whatever GitOps tooling you have basically means that it will eventually just come up to state and do its job without really anything, because of all that automation and these multi-cluster networking bits, it'll come up to state without really any extra work that you need to do. Super important. Okay, so we mentioned earlier that you likely, you're going to take a good guess or an educated guess on how you want to bin pack applications up front into shapes, but you need to reassess your bin packing and make adjustments as needed. Since you've abstracted away tenants, you can move teams after they've initially been set up. Here's an example. Let's say team 2 and team 4 were initially grouped together, but you notice that team 2 is quite noisy. Meanwhile, team 1 and 3 could benefit from running more applications together for cost efficiency. You can move team 4 to the shape with team 1 and 3 and leave team 2 on its own, right? So now team 2 is critical. It's got its own cluster. It's single tenant, multi-cluster. But then you've taken this other this smaller service, I guess, or the service that's just better, that runs better with these other 2 teams, and co-located them. So you've created some efficiency and some reliability. This approach works well for stateless applications. Stateful applications can also fit this model, but it's a little more tricky. Most customers I work with have specific shapes within their fleet for stateful clusters. And then they use specialized operators and tooling to handle migrating the state across multiple clusters of those applications. So in the end, again, you have this config layer cake. At the top, you have services and applications organized into teams performing their tasks. And then at the bottom, you add clusters as needed in the infrastructure tier. This infrastructure, which is the basis of my earlier next talk, abstracts applications and teams away from the clusters to provide a robust foundation to build that nice user experience of an IDP on top of. Let's discuss the personas or users of your IDP. It's not likely that they'll all be the same, right? There's going to be some variance between different users that you have, or different personas, if you will. The idea here is to treat an IDP like a product, right? So when you're building a user experience, identify a persona, then like function sort of as a product manager, interview those users and gather their requirements and develop suggestions on how to address the needs that they have with features, right? And then at the end, you'll have a list of things you want to build and you need to go through a prioritization exercise. So when designing the UX for the platform, again, think like a product manager. For example, you might find that you have technical developers, advanced users, if you will. And these users are proficient in Kubernetes and Linux and want full control. I'll provide them access to the Git repositories where they can ship configuration and they're going to be happy, right? And then you'll have developers that are looking for an easier abstraction to use. And you could do that with Customize or a Helm chart exposing values file that simplifies their tasks. Again, they're interacting with Git, but they're not using the full Kubernetes API surface area. And then you might have some developers that prefer to work through a UI, right? So you could build a UI for making and deploying change across applications that run within a team. Lastly, I mean, it wouldn't be a talk of any merit in this day and age if I didn't mention data scientists and AIML. But that's a user who you're likely going to have to support, and they're going to have a completely different set of requirements and expectations. So, for example, you could provide a notebook as a service through Kubeflow, or build Ray on top of that Kubernetes infrastructure with a different UI and UX. And in this way, you've got a bunch of different workflows and UX and maybe even UI running on the same infrastructure. You get the benefit of running infrastructure efficiently while not pigeonholing everybody into the exact same experience. So in summary, I hope I've clearly conveyed my perspective on building platforms on top of Kubernetes clusters. I'm trying to emphasize the importance of abstracting your tenants from the actual infrastructure through automation, and focus on creating golden paths for tenant CRUD operations, not cluster deployment, right? Onboard a tenant, add capacity to a tenant, make a change to the tenant, but not specifically giving every single one of your dev teams a button to give them a cluster, because that's not going to be manageable over time. Again, my name is Nick Eberts. You can find me on the socials at the tag here, and feel free to argue with me about all the things that I said that you don't like. I'm happy to. I appreciate your time. I hope that you have a great platform con, and thank you.